Example number 51, you'll be told to evaluate the integral of x squared plus 5 dx over x plus 2 by x squared plus 3. So here you can see the highest exponent of the polynomial in the numerator is 2. The highest exponent of the polynomial in the numerator is 3, because this is x times x squared is x to the power 3. Have you seen? So you see you can resolve it into partial fractions. So here we have x squared plus 5 over x plus 2 into x squared plus 3 will be, this is a linear factor, isn't it? So a linear factor is simply a over x plus 2, a over that linear factor, a constant over that linear factor, isn't it? Yeah. The second one is a quadratic factor, isn't it? So quadratic factor will be bx plus c, isn't it? Because it is a quadratic factor. Are we together? So bx plus c over that given quadratic factor, which is x squared plus 3. Are we together? So from there, chap, mambo ni chap. So we have the LCM is what you have here. This times this, which is x plus 2 into x squared plus 3. So x plus 2 goes here, times a, you have a into x squared plus 3, isn't it? Then we have our plus bx plus c. Then this goes here many times? X plus 2 times, isn't it? Are we together? It goes x plus 2 times. So at the end, you simply open that bracket. Open them. What do we have? Remember, we are comparing. The denominator is the same as the denominator, isn't it? So we are comparing the numerator with the numerator. So numerator, this side is x squared plus 5. And the numerator, this side is this. So we simplify this, isn't it? Are we together? So can you start collecting? Here we have a into x squared plus 3. Then it is plus, open the other bracket. What do you have? Bx times x is bx squared. Bx squared, bx times 2 is plus 2bx, isn't it? C times x plus cx, then plus 2. If you expand that. Are we together? Isn't it? So start comparing. The coefficient of x this side must be the same as the coefficient of x the other side, isn't it? Are we together? Yes. So what is the coefficient of, let's start with x squared. The coefficient of x squared this side is 1, isn't it? So it means 1 is equals to coefficient of x squared the other side. The first coefficient of x squared is a times x squared is a, isn't it? Are we together? You are comparing the coefficients. This is what I mean. Here, if you remove x squared outside, what are the coefficient of x squared? It is a times x squared. You get a, another coefficient of x squared here is b, isn't it? A plus b. You join the coefficients of x squared together. Are you seeing? You are done. You go to the coefficients of x. So if you put x outside, so you have 2bx and plus 2b and plus c, isn't it? Are you seeing? Plus 2b is a coefficient of x, positive is silent, isn't it? And plus c is a coefficient of x. So you can see x into 2b, you get your plus 2bx, x into that, you get your plus cx, isn't it? So you collected the coefficient of x. You now collect the constant terms, isn't it? The first constant term here is a times 3, isn't it? A times positive 3, you get plus positive 3a. The next constant term there is plus 2 plus 2c. So you see, you've collected everything. Are we together? And this side, what do we have? 1x squared plus 5. So from there, start comparing the coefficients. Start comparing the coefficients. The coefficient of x here is, of x squared here is 1. So it means 1, let us start with that one. It means a plus b is the coefficient of x squared, and the coefficient of x squared is 1. So a plus b is equals to 1. You compare coefficients, okay? The coefficient of x is 2b plus c is the coefficient of x. Coefficient of x this side is, because there's no x this side, meaning coefficient is 0, isn't it? That's why it is not there. Are we together? Meaning this side we have 0x. So coefficient of x this side is 0, coefficient of x that side is 2b plus c. So you compare coefficients. Is that okay? Move to constant term. The constant term, the other side is 3a plus 2c, isn't it? And the constant term this side is 5. You see? So you see, this is simultaneous. You can solve using matrix very fast, isn't it? You solve it using matrix very fast. So can you do that very fast? So this is A plus B plus 0C is equals to 1. Then here is 0A, because there's no A, isn't it? Plus 2B plus C is equals to 0. Then here 3A plus 0B plus 2C is equals to 5. So from there you can see the coefficient matrix is anything without a coefficient has a coefficient of 1, isn't it? 1, 0, 3. Then here positive 1, positive 2, 0. Then here 0, 1, 2. Positive 0, positive 1, positive 2, 0, 1, 2, isn't it? Are we together? See, that's the coefficient matrix. Yes. Then that coefficient matrix times A, B, C, you are supposed to get the solution, which is 105. So can you press enter that matrix in the calculator and let us get those determinants? Give me the value of A, B, and C very fast. Start. So Cramer's rule, A is equals to A. So it means D over D. So D over A over D. So first of all, get D, determinant of this coefficient matrix. What is D? So that one will give you A. Then you get your B with the same B is equals to B. D of B over D. You get that. Then the next one is C is equals to C. D over D. D of C over D. So get me the determinant of this coefficient matrix D. From the calculator, what do you have? Determinant of which matrix? Select the matrix. Shift and select the matrix. It was A. What do you have? 7. So it means to be 7. So where there is D, you put 7 all the way through. So you found D, isn't it? Are we together? D is the determinant of this matrix, isn't it? Are we together?
Yes.
So after getting that D, you found all the values. Then you ask is you go back, then you shift, you come to matrix, then you say the determinant is number 7. Then you shift to select the matrix you're looking for. Which matrix are you looking for? Matrix A. Determinant of matrix A, then it gives you the answer. You see that? So after that, start D of A, meaning you substitute the column of A. A is in the first column. You substitute the first column with the solution, isn't it? Meaning you substitute this column with the solution 105. Where there's 103, you now put 10. Are we together? Yes. So what do you get? Nine. Good. So you have, that is 9. So you are done. Go to B, meaning B is the second column. Meaning the second column of this matrix you substitute with the solution, isn't it? Then give me the determinant of the certain matrix for you to get D of B. Get D of B. Substitute that. Shift and select the matrix you're looking for. Select the matrix you're looking for. Yeah, select the matrix. Select the matrix. Delete that form.
shift, then you select the matrix.
What do you have to be D of B? -2. So that is -2. Then get D of C. C is the third column, meaning the third column of this coefficient matrix to substitute with the solution. So put solution in the third column and get me D of C. Substitute to get me D of C. What have you found? 4. So you put that. So you see, you found the value of A, B, C, isn't it? You found the value of A, B. Sasa mambo ni nyue, chap, you substitute there, chap, and you are done. So it means this is equals to, where there is A, you put the value of A. A is 9 over 7. So where there is A, you put the value of A is 9 over 7. Where there is B, you put the value of B, -2 over 7. B is -2 over 7. Where there is C, you put the value of C is 4 over what? 7. So you substituted those three values. So what do you see here? Very simple thing. So this is what it is. Meaning, if you want to integrate this, you subdivide this. You subdivide this because this is a common denominator. Are you together there? That is a common. So 9 over 7, we have 9 over 7 into 1 over x plus 2, isn't it? Then it is plus -2 over 7. Are we together? -2 over 7. Or remember, if you differentiate x squared, you get 2x. So you can leave that 2 inside. You have -1 over 7 into 2x over x squared plus 3. Because if you differentiate x squared plus 3, you get 2x. What is in the numerator? So you take 2x inside. Is that okay? Then it is plus 4 over 7 into 1 over x squared plus 3. Meaning this is a common denominator. Meaning this over this plus this over this. Have you seen that? Are we together? Yes. Meaning if you have A plus B over C, that is A over C plus B over C. That is what we've done, isn't it? So it is -2 over 7x over x squared plus 3, which gives you this, isn't it? Then it is plus 4 over 7 over x squared plus 3, which gives you this, if you simplify. Are we together? Are we together there? Yes. So, on this side of the equation, we have x squared plus 5 over x plus 2 into x squared plus 3. So what do? You simply introduce integral on both sides of the equation with respect to x, with respect to x, with respect to x, with respect to x. So you see, the integral which you are given is this. You will only introduce the limit of the integration. Is that okay?
Yes. Yes.
So start with this one. What is the answer? du, this is ln of u. If you let u to be x plus 2, meaning du is equals to dx. So it's like du over u. You get the answer to be ln of u, isn't it? Yeah, so it means here if you integrate du over u, you will get ln of u, ln of x plus 2. Are we together?
Yes.
You are done with that? If you move to this one, you let v to be x squared plus 3, meaning if you differentiate v, you get 2x dx. dv with respect to x, you get 2x, isn't it?
Yes.
You take dx, the other side is 2x dx. So 2x dx, the whole of this is dv. So it is dv over v, isn't it? So you see you are integrating dv over v. You get ln of v. And v is what? Are you seeing you are done with that?
Yes.
Are we together? Yes. So here, the answer here is ln of u. and your u you can see is x plus 2. The answer here is ln of v, and you can see your v is x squared plus 3. What about that one? Tan inverse, isn't it? Isn't it? This is tan inverse. You simply take 3 outside. If you take 3 outside, you get tan inverse. What it means here is you have dx over, if you remove 3 outside, it is, take this 3 outside, it is 3 into x squared over 3 plus, isn't it? See, that is what is inside. So if you take 3 outside, it becomes a third outside. And a third, remember 4 over 7 was outside, so it means outside this integral you now have 4 over 21, isn't it? 7 times 3 is 21, isn't it? Then into dx over, what is this? See, this is x over root 3 all squared plus 1. Are you seeing that? Because square times root 3, you go back to 3. Is that okay?
Yes.
Tuko pamoja? So, if you look at this, let me write it up here. If you are given the integral of dx over 1 plus a squared x squared, you are supposed to get 1 over a tan inverse of kx. So it means here if you have the integral of dx over x over root 3 squared plus 1, which is the same as 1 plus this, you are supposed to get 1 over a, 1 over root 3. What is your a? See, here is 1 over root 3 times x all squared, meaning a squared is 1 over root 3. So it is 1 over 1 over root 3. A is not 1 over root 3, but 1 over root 3, isn't it? Are we together? So it is 1 over that, then tan inverse of ax. Tan a is 1 over root 3x. So 1 over 1 over root 3 is the same as root 3, isn't it? So that is root 3 tan inverse of 1 over root 3x. You've integrated that, and outside you have 4 over 21, isn't it? Yes. Outside you have 4 over 21. So you have 4 over 21 which was outside, 4 over 21 which was outside, meaning you will be multiplying this by 4 over 21, isn't it? You will be multiplying it by 4 over 21. So if you multiply that with 4 over 21, you get 4 root 3 over 21 tan inverse of 1 over root 3x. Go back to your problem. Go back to your problem. So start. This is 9 over 7. If you integrate the x over x plus 2, you get ln of x plus 2. Isn't it? You are done with that. Then here we have minus 1 over 7. If you integrate this, you get ln of x squared plus 3. We've done with that, isn't it? Then the last one, we have 4 over 7. You have 4 over 7. If you take the 3 outside, it means it will be times 1 over 3. Then you remain there with the dx over x squared over 3 plus 1. X squared over 3 plus 1 is the same as x over root 3 squared, isn't it? Are we together? Isn't it? So from here you can see x over root 3 squared is the same as 1 over root 3 squared x squared. So your a is 1 over root 3. Are we together? 1 over 4 over 7 times 1 over 3, you get is 4 over 21. So if you deal with that, you have here 9 over 7 ln of x plus 2 minus 1 over 7 ln of x squared plus 3, then plus. Here you're supposed to get 1 over a. 1 over 1 over root 3 is root 3. Times 4 over that, so it is 4 root 3 over 21 tan inverse of ax. A is 1 over root 3x. What we got that? So from there, you simply introduce the limits. The limit is from 0 to 1, so you put your limits everywhere. 0 to 1, 0 to 1, 0 to 1, then at the end, you come and you put your limit, that is 0 to 1, then at the end, you put your limit 0 to 1. Solve that problem. Substitute. Upper limit where there is x, you put 1. when answer is equals to 1, then you substitute the formula. Go to the calculator. Go to the calculator. This is equals to, put answer is equals to 1. Say 1 is equals to 1. Don't be afraid to press the calculator. So you have 9, 1 is equals to 1. So you have 9 over 7. Substitute. Take this one to normal. Is it line 10, man 10? Oh, then it goes back to normal. Hey. Well, now that you've reset it, can you now get me this? Where there is x, answer. Yes. 2. I took 2 inside because when you take v to be x squared plus 3, if you differentiate, you get 2x dx. So 2x dx, the whole of this is dv. So it is dv over v. That is why it was supposed to be negative 2 outside. So 2 I've taken inside because the whole of that 2 is part of dv. Are you see?
Yes.
Good. What do we have? Yeah, just go back. Oh, you found? Yes, 11.11. That is upper limit.
Yes.
Upper limit is 11.11. Then minus lower limit 0 is equals to. You got? 0.7. Good. 0.73. That is very good. I like that speed. That is a speed of someone who is very serious. So what do you have here? 11.11 minus 0.73. 10.38. Good. So 10.38. And you are done with the definite integral. Very simple, isn't it? Very simple.